Co-located battery and renewable projects come in all different shapes and sizes. Some projects are retrofitting an existing asset under a PPA or subsidy with a new battery to take advantage of the existing grid connection, or to deal with the increasing number of negative priced hours which are impacting overall revenues. While other co-location projects are greenfield projects, starting afresh, using the advantages that multi-technology at a specific site can provide. In each case, the project economics will look significantly different. Accurately modelling energy flows aligned with existing contracts is essential for accurate cash flows and therefore essential for optimal investment decision making. Let's take a look at the retrofit case. It's very likely that the existing solar or wind asset will have a pre-existing offtake agreement. This could be a subsidy, such as the Contract for Difference schemes in the GB market or the EEG in Germany. There are some fundamental differences in these two contract types and how they're settled. However, depending on when they were awarded, both have a strike price that knocks out in the event of negative wholesale reference prices, sometimes after one interval and other times after a certain number of subsequent negative price intervals. Or, this existing setup could be a PPA. A common PPA type is pay as produced, so the generator is paid for every megawatt hour they export. These pay as produced contracts will typically have a volume tolerance clause, meaning that if a battery is retrofitted to the site, the renewable asset will need to have first right of way over the grid connection. Also, given the increasing prevalence of negative wholesale pricing, it's not uncommon for newer PPAs to have knockout clauses relating to negative power prices as well. These contract provisions can be material, and it's important to ensure that they're modelled correctly. In Gridcog, it's easy to reflect these kinds of contracts. Users can define strike prices, market reference prices, including if these are not direct wholesale prices such as market value solar in Germany. Negative price adjustment clauses can also be modelled, including setting the minimum number of negative price intervals that must occur before the contract knocks out. Let's take a look at an example solar site in Canterbury, looking at adding a battery to its site. The site has a PPA with a strike price of £65 per megawatt hour and knocks out in the event of negative prices. The site also earns regos and pays for their PPA balancing costs. Once this is all set up, the software will run the co-location scenario. This allows you to test different battery sizes for the co-located site. You can then evaluate the financial metrics associated with each battery size to support your investment decision. All results are based on transparent energy flow and cash flow data, whilst ensuring that the existing commercial arrangements for the solar asset are fully respected. Now, if we were looking at a greenfield site, the project design would be different. This is because, for this type of project, you want to test different offtake structures for the complete site. The offtake structures will vary depending on the level of risk or merchant exposure the asset owner is able to take. These structures could be floors, tolls, base or peak load PPAs, or a full merchant co-optimization. All of these options can be modelled and compared against each other in Gridcog. This gives you confidence in both the financial outcomes of your project, but also how assets will physically perform. There is not a rule of thumb for co-located projects. The market is evolving quickly, and it's exciting to see the wide variety of commercial models being adopted. If you'd like to find out more about how Gridcog can help you accurately model your commercial options, then get in touch.